Hello everybody, welcome into another lesson. So today we are going to continue on with our discussion of conic sections, and today we will be talking about the ellipse. So I have an ellipse graphed here. If you look at this, this looks like a circle basically that's elongated more on one axis than the other. It looks like an oval or a football, and that's basically what it is. A football is definitely, in 3D it would be called an ellipsoid, but it's very elliptical in shape. So you have two forms of the equation of an ellipse. In this first example here is where the major axis is the x-axis. How do you know which axis is the major axis? That is going to be whichever denominator has the bigger number. In general, the a squared means that's the major axis. That's going to be your bigger number. The general form of the equation of an ellipse, regardless of which axis is major, is x minus h squared over either a squared or b squared, depending upon which axis is major, plus y minus k squared over either a squared or b squared equals 1. And your center, so the center of the ellipse is always at the coordinates hk. So if I take x minus h, set that equal to 0, my x coordinate is h. If I take y minus k, set that equal to 0, I'll get my y coordinate of k. Therefore, that's my center. Now, regardless of which axis is major or not, in order for the equation of an ellipse to be in standard form, the right-hand side always has to equal 1. Always. It always got to equal 1. And in order to find what's called, well, first let's talk about a minor axis. So you got your major axis, in this case is the x-axis because the bigger denominator is below the x. That means it's going to be more elongated on the x-axis and shorter on the y. So the major axis is the x-axis, the minor axis is the y-axis because a smaller number is below the y. Then we have something called foci of an ellipse. It's the plural form of focus. So far we have talked about the focus of a parabola, and it's kind of the same idea, only you have two because you're going to have two for an ellipse. The plural form of focus is foci, or foci, however you prefer to pronounce it. But to find your foci, it's always c squared equals your a squared minus b squared, and then you're just going to solve for plus and minus the square root of a squared minus b squared. And then your foci or foci, they're based off of which axis is your major axis. In this particular case, the x-axis is the major axis. So what you're going to do is take the coordinate, the x-coordinate of your center, add or subtract c from that, and you'll have two x-coordinates, but you'll leave your y-coordinate alone. Those would be the coordinates of your foci. Now, you're still going to, of course, you have to get the endpoints of your axes. So, to get the endpoints, if you want to get the x endpoints, you'll just take the x-coordinate of your center, you'll add and subtract a from that. So, over here you'd have h plus ak, over here you'd have h minus ak. Those would be your x endpoints, and to get your y endpoints for the minor axis, you have to take the y coordinate of your vertex, first add b to that, and then subtract b, and then you'll have the endpoints of your minor axis, and then you can draw your elliptical shape. And the foci, just like in a parabola, will always be inside of the ellipse. They'll always be inside of the ellipse. So in this case, I have x squared over a squared plus y squared over b squared equals 1, with the center at 0, 0, because it's just x squared, just y squared. The center is at the origin. I put my foci in here somewhere, And then because they're going to be inside equally distant from the center, the foci are always equally distant from the center, so are the endpoints of the major axis and the minor axis. Now when it comes to circles, that was our first conic section we did. They are very related to ellipses because you could argue then, granted your right hand side is probably going to equal some other number than 1, but if you take that other number other than 1, divide the right hand side by that number, you'll get 1, and then you would have the exact same length for both your x and your y axes. And well, a circle is equal all around. It's an equal radius and diameter all around. So in a sense, a circle is a special type of ellipse because it's fully even, unlike a normal ellipse, which is not. So that's how circles relate to ellipses. Now, we could also, and it won't change much actually, you can also have ellipses where you have the major axis as the y-axis. So if I make this x minus h squared all over b squared plus y minus k squared over a squared, now the bigger number, the bigger denominator has gone below my y. That means my major axis is actually the y-axis, and then my minor axis becomes the x-axis. The center still doesn't change, that's hk. You don't change how you get the foci, that's still c squared equals a squared minus b squared. The only difference is going to be where the foci are located. So again, those always relate to your major axis. So if y is your major axis, you'll leave your x-coordinate alone, but you'll take your y-coordinate of the vertex, you'll add and subtract c from that, and you'll have your 2 coordinates of the foci. And in this case, why don't we switch this around where we have the center still at the origin, that's not going to change, but we'll have x squared over b squared plus y squared over a squared. A simple ellipse where the y-axis is the major axis and the x-axis is the minor axis. So the center's still at the origin. We'll make the y-axis the major axis. We'll make the x-axis the minor axis. Now we will go ahead and connect these, and you'll see how this is going to look when the y-axis is major. So you see it's more elongated along the y-axis than it is the x-axis. So here's your center at 0, 0. We'll say your foci are in here somewhere. We'll call those point F, right, for your foci. Now, your endpoints for the major axis, so that's your y-axis. The y-axis is the major axis, so that means to find those endpoints, you'll leave your x-coordinate alone, but you'll take that k, you'll add and subtract that a from it, so you'll actually, for above it would be plus a, for below it would be the point hk minus a. And then we still have to get the endpoints of your minor axis. The minor axis is the x-axis, so this time we're going to affect the x-coordinate, so that would be h plus b comma k. We'll leave the y-coordinate alone, and then of course you would have h minus b comma k. So that in general is how you're going to find the that's how you will find the coordinates for the endpoints and the foci in the center for your ellipse. So let's do a couple examples where we have an easier equation given to us where the x-axis is the major axis. We'll start with the vertex of the origin. I'll also specify that. So let's pick the x-axis is the major axis. Why don't we do this one? So x squared over 9 plus y squared over 4 equals 1. Okay. So we have x squared over 9 plus y squared over 4 equals 1. Well, the bigger number is below my x. That means my x-axis is the major axis. X-axis is the major. That means the y-axis is the minor. Now, so that means the bigger number, the bigger denominator is always our a. If a squared equals 9, well, that means a has to equal plus and minus 3, right? That means then my b squared is 4, because the numbers you get in the denominator are always squared. They're a number squared. So b squared equals 4. That means b has to equal plus and minus 2. It's very helpful to solve for those. Now, let's find the vertex. Not the vertex, excuse me, the center. The center of this ellipse, well, it's just x squared, just y squared, so the center is located at the origin at 0, 0. Now, the next thing we probably should do, let's find the endpoints. So, the endpoints of this ellipse. So here's my center at 0, 0. You'll see a graph here in a second, but let's get the endpoints. So if my x-axis is the major axis, I need to take this x-coordinate of the center, being 0, add and subtract 3 from that. So my endpoints will start out then, we'll have both plus and minus 3, 0. For my x-axis, so that's going to go right here and right here. So there's 3, 0. There is negative 3, 0. But we also have to consider endpoints for the minor axis too. To find it for your minor axis, the y-axis, you'll take the y-coordinate of your center, you'll add and subtract b from that. Well, you'll leave your x-coordinate alone, but 0 minus 2 is negative 2, 0 plus 2 is positive 2, so you'll get coordinates of 0, plus, and minus 2. So that's going to go up here. Alright, so let's connect this now. And then the very last thing we need to do are find the coordinates of our foci. So foci is given by c squared equals a squared minus b squared. So c squared equals our a squared of 9 minus our b squared of 4, which is going to equal 5. So c equals plus and minus the square root of 5. So how do we find the coordinates of our foci? Well, the foci, that's always going to go, again, you're going to take the x-coordinate of your center. Since the x-axis is the major axis, you would take the x-coordinate and affect it. If it were the y-axis being the major axis, then you would affect the y-axis. The foci are always based on your major axis. So I'll take that plus and minus square root of 5, I'll add those to my x-coordinate of 0. My foci can be found at both plus and minus square root of 5, 0. So let's figure out what the heck is the square root of 5. I know it's going to be a little bit more than 2, but let's see where that puts us exactly. What is the square root of 5? I like a decimal approximation. Alright, so the square root of 5, that's approximately 2.24. That's going to put me about right there. And then in the negative realm, that will put me about right there. So here's point F, denoting my foci. Here's my center at 0, 0. Here is 0, 2. Here's 0, negative 2. And I have fully graphed this ellipse, with my major axis being the x-axis, my minor axis being the y-axis, the center at the origin, and then my various endpoints and foci. That's how you're going to graph an ellipse. Let's do another one with the x-axis being the major axis. With vertex at the origin, of course. So these values are going to change, of course, but I'll keep the general format up. The center will be the same even. I'm not changing the center. Okay. So what do we get here? We get x squared over 64 plus y squared over 9 equals 1. Alright, so we have x squared plus 64 plus y squared over 9 equals 1. Well, again, the bigger denominator is below my x, so the x-axis has to be the major axis, which could only leave my y-axis being the minor axis. Well, the bigger number, my a squared, well, my denominator is already a squared below the x, so a squared equals 64. That means a could only equal plus and minus 8. Now b squared, that's the number below the y, so that b squared equals 9. That means b equals plus and minus 3. Alright, so great, we found that. And this equation is in standard form because the right-hand side also equals 1. It always has to equal 1 and nothing but that. So, looking at the center, I just have x squared and y squared giving me a center at 0, 0. I can at least go ahead and plot the center to start. Now, what about endpoints? So since x-axis is the major axis, I'm going to take that plus and minus 8, add them to my x-coordinate at the center of 0. So of course I'll have plus and minus 8, 0 for the x endpoints. 4, 5, 6, 7, 8. So there's positive 8, 0. Yeah, this is going to be a big one. And then we're all the way back here for negative 8, 0. Now, what we need are, of course, the minor axis endpoints being the y-axis. This time we'll leave the x-coordinate of the center alone. That's going to be 0. Now take that plus and minus 3, add that to your y-coordinate of the center. You would just get 0 plus and minus 3. So those will be right here. Here is 0, 3. Down here, that's going to be 0, negative 3. Great, so we plotted all the endpoints. Let's go ahead and start making a connection here. One loop. In my opinion, these are a little bit easier to draw than a circle because it's expected to be crooked. And I always draw crooked. I can never draw straight. Good thing I'm not an artist. Anyway, I got my center here at 0, 0. Got my various endpoints. Now, what's left are to go ahead and find the foci. So that's, again, is c squared equals a squared minus b squared, which means then a squared is 64 minus my b squared of 9, which is going to equal 53. So c equals both plus and minus the square root of 53. Now again, my foci are always based on the major axis. In this case, it's the x-axis. So I will take that c, both values plus and minus, add them to my x-coordinate of the center. I'll get my foci at plus and minus the square root of 53. That should be 55. Gosh, excuse me. 64 minus 9 is 55. Brain fart, forgive me. That should be plus and minus the square root of 55. Long day, forgive me. So plus and minus square root of 55, 0. Let's figure out what the heck the square root of 55 is. That's about 7.42. So that's about right there. There's your first focus, right about there, which means it's going to be about here for your second focus in the negative area, all the way back. And then you have completely graphed this ellipse based on the major, minor axis, the center, the endpoints, the foci, all those good things. Now, let's do a couple with the x-axis being major where the center is not at the origin. Let's see how that's going to be affected. And then we'll switch to the y-axis major. So, let's just completely erase that. Yes, we're going to keep the major axes. That much is true, but the center is even going to change. Definitely the endpoints. We'll erase that part here. Alright, so what do we got here for the first example? We have the quantity of x minus 2 squared all over 16 plus the quantity of y plus 1 squared is equal to 1. Alright, so we have x minus 2 squared over 16 plus the quantity of y plus 1 squared equals 1. Well, we don't have a denominator for y plus 1, right? Well, we can just use the principle that the denominator is an invisible 1. So if it helps you, go ahead and put a 1 there for your denominator. And this clearly should demonstrate that the x-axis is the major axis, your y-axis is minor. So that means a squared is 16, so a has to equal plus and minus 4. Your b squared is 1, so b equals plus and minus 1. Now what is your center? Well, take your x minus 2, set that equal to 0. Your x coordinate of the center is at 2. Take your y plus 1, set that equal to 0. Your y coordinate will be negative 1. So your center is going to be located at 2, negative 1. There's my center. In fact, I better not make that too big. We're actually going to have a small ellipse here. But there's my center. Now, the endpoints. So the x-axis is still the major axis. So we need to take that a of plus and minus 4, add both of those to my x-coordinate of 2. Well, 2 minus 4, that's negative 2, negative 1. And then we're also going to have then 2 plus 4, which would give you 6, negative 1. So 3, 4, 5, 6. Here is going to be 6, negative 1. Here is negative 2, negative 1. So negative 2, negative 1, positive 6, negative 1. And then let's find the endpoints for the minor axis. Now, you're going to leave your x-coordinate alone this time. For both of these, you'll leave your x-coordinate alone. That'll stay 2. But if I take that negative 1 first and subtract 1, I'll get 2, negative 2. And then if I take that negative 1 and I add 1, I'll get 2, 0. So those are my endpoints for my minor axis. So negative 2, negative 2, I'm sorry, 2, negative 2, 2, 0. So let's go ahead and really draw this. First I'll label these. We have 2, 0. Then we have 2, negative 2. So let's go ahead and connect these here. Not the best ellipse because it went over my divide, but you see it's clearly more elongated on the x-axis. Here's my center. All that's left to do now are find my foci. So c squared equals a squared minus b squared, which in this case is going to be a squared is 16 minus b squared, which is 1. That equals 15. So c equals plus and minus the square root of 15. So now what I have to do to get the coordinates of my foci, once again, the foci are based off of your major axis. So I'm going to take the x-coordinate of the major axis, add and subtract that square root of 15. So those can be found at 2 plus and minus the square root of 15. Then I leave my y-coordinate of -1 alone. So there's my foci. Let's see exactly what the heck I get from my foci. Approximately. Whoops. Negative of the square root of 15. Let's add 2 to that. You get about negative 1.87, which is about right there. There's the first focus of the foci. Now, if I just simply take positive square root of 15 and add 2, I get about 5.87, which is about right there-ish. Yeah. There's my other focus of the foci. So there's all my foci, there's all my endpoints, there's my center, and that's how you're going to graph a center, not the ellipse. But let's do one more, where the x-axis is the major axis, and then you have, of course, the center's not at the origin. We're going to keep the same major and minor axes. Whoops, I didn't mean to erase the endpoints part. I'm going to keep that up. But I do want to erase everything below that. It's good to keep these formats up. Okay, so another good one, we have x plus 2 quantity squared all over 9 plus the quantity of y plus 2 quantity squared all over 4 is equal to 1. All right. So this particular equation of this particular ellipse is x plus 2 quantity squared divided by 9 plus the quantity y plus 2 squared all over 4 equals 1. Well, clear to see the larger denominator belongs to the x side, so the x-axis is the major axis, which means the y-axis is the minor axis. So my a squared is 9. That means that a is both plus and minus 3. B squared is 4, so b is both plus and minus 2. Now what's my center? So the center, I take that x plus 2, set it equal to 0. I'll get a x coordinate of -2. Take the y plus 2, set it equal to 0. I'll get a y coordinate of -2. So I have a center of this ellipse located at -2, -2. There's my center. All right. Let's calculate the endpoints, which once again are based on, for your major axis, you got to take your x coordinate of your center, add and subtract a from that. So -2 minus 3 is -5. Then just leave your y coordinate of -2 alone. And then take your -2, add 3 to that, you would get +1 and then -2. So there's your x-axis endpoints. There's -5, -2. And then you're going to have +1, -2. Now, we need to find the minor axis endpoints. So this time for both of these, you're going to leave your x-coordinate alone, but you'll take that -2 first, subtract 2 from that. -2 minus 2 is -4. For your second coordinate, once again, leave that -2 alone, but this time add 2 to -2, you get 0. So you have -2, -4, and -2, 0. So let's go ahead and draw this ellipse here. So there's the ellipse. Last thing to do are find the foci. So c squared equals a squared minus b squared, which would end up giving me 9 minus 4, which is 5. So my c equals positive and negative square root of 5. And again, the foci are always based off of the major axis. So take your x-coordinate of the center, add and subtract the square root of 5 from that, so you'll get the foci at -2 plus and minus the square root of 5. Then your y-coordinate just stays -2. Now let's go ahead and figure out just what the heck that is approximately as a decimal. So negative square root of 5, let's just do -2 first. That'll put you at about -4.24, approximately right in there-ish. And then let's take positive square root of 5 minus 2. That's about 0.24, which would be about right there. So there's your foci now, and there's the graph of this ellipse with all this given information we were able to obtain. All right, let's shift gears to where we have a major y-axis and a minor x-axis. We'll do a couple at the origin, and then we'll do a couple not at the origin. So let's switch a little bit of terming here, okay? So the next several, the y-axis will be the major axis, the x-axis will be minor. But the process for how we go about finding stuff really isn't going to change all that much. So the center is going to be at the origin at 0, 0 for the next two at least. So for example here, let's say this time I have something like x squared over 4 plus y squared over 9 equals 1. So I have x squared over 4 plus y squared over 9 equals 1. Well, the bigger number is definitely below the y, isn't it? That means the y-axis is the major axis and the x-axis is the minor axis. So the bigger number is always the a squared, which would be 9, which means a is both plus and minus 3. So the smaller number is the b squared, that's 4, so b is both plus and minus 2. And if you look at this, you just have x squared plus y squared, so your center is at 0, 0. Now we need to obtain some endpoints. So let's deal with the major axis endpoints first. So this time the y-axis is the major axis. So let's take, we're going to leave the x-coordinate of 0 alone, but we take the y-coordinate of 0, add and subtract 3 from that, you'll get 0 plus and minus 3 as your major axis endpoints. Let me graph that center here. Now 1, 2, 3, so here is 0, -3, 1, 2, 3. Alright, so there is 0, 3. Now we can find minor axis endpoints. In this case it's the x-axis, excuse me. So we're going to affect the x-coordinate of the center. So we'll take that b, that plus and minus 2, add it to 0. Well, you'll get plus and minus 2. And then your y-coordinate 0. So here is positive 2, 0. Over here is going to be -2, 0. And now we can go ahead and start connecting these. And you see the shape of this ellipse, definitely more elongated on the y-axis. Last thing to do is find the foci. So for the foci, that of course is going to be c squared equals a squared minus b squared, which in this case a squared is 9 minus 4, which would equal 5. So c equals plus and minus the square root of 5. So the coordinates of my foci, this time the y-axis is the major axis, so we'll leave the x-coordinate of the center alone. But let's find the y-coordinates of the foci. We just add that plus and minus square root of 5 to 0, you'll get 0 plus and minus the square root of 5. And there's your coordinates of the foci. Now, I know it's a little bit bigger than 2, but I don't remember what the square root of 5 is offhand. So you get about 2.24. So there's your first focus. Your second focus then would be down here, about negative 2.24, along the y-axis. So there's that ellipse with everything graphed, this time with the y-axis being the major axis. All right. Let's do another one where the center's still at the origin, and then we're going to do a couple where the center's not at the origin. So let's go ahead and leave that format in place here for now. What do we get this time? So we have x squared all over 4 plus y squared over 25 equals 1. So x squared plus 4 plus y squared over 25 equals 1. Okay, so definitely the bigger number is below the y, so the y-axis is the major axis, the x-axis is the minor axis. So that means then my a squared is 25, so that means that a has to be both plus and minus 5. Which means my b squared is 4, so b has to be both plus and minus 2. We've got those out of the way, and we just have x squared and y squared giving us a center at the origin at 0, 0. So let's go ahead and fill that in on the graph. Endpoints now, let's start with the major axis first. If the major axis is the y-axis, that means at first we're going to leave the x-coordinate of 0 intact. Now, the y-axis then, we're going to take our y-coordinate of the center, add and subtract that 5 from it, so you'll get 0 plus and minus 5 would be your endpoints. So 2, 3, 4, 5. All right, so here is 0, negative 5. Now we got to go up to 0, positive 5, which is going to be right there. Okay. Then, of course, we got to find endpoints for the minor axis. That's going to be the x-axis. So you'll take your x-coordinate of the center, 0, plus and minus 2, and then you'll end up getting plus and minus 2, 0 for the endpoints of your minor axis. So here's 2, 0. Right here is negative 2, 0. And let's go ahead and graph these. Let's graph that. Okay, so there's my endpoints. Here's my center at the origin. Only thing left to do are find the foci. And you're also probably wondering, well, wouldn't you want to put the foci before you graph this? No, I'll tell you why. Because it's too easy to connect your foci on accident together as opposed to your endpoints. That's why I do the foci last. But in this case, c squared equals a squared minus b squared, which would be 25 minus 4, or simply 21. So c would have to equal both plus and minus the square root of 21. Now, again, the foci go based off of your major axis. So you'll take your y-coordinate, add those plus and minus square root of 21, so the foci will be at 0 plus and minus the square root of 21. So let's see about where the heck that puts me. So square root of 21, that's about 4.58 in the positive, so that's about right there, which would be about negative 4.58. That'd be all the way down here. So there's both of my foci inside of this ellipse, and there's the graph. All right, let's do a couple where the center is not at the origin in true fashion, like I said we were going to. In fact, let's just erase that altogether. It might be easier. Alright, so we're keeping the same axes, major and minor. That hasn't changed. The center is for sure going to change. Endpoints, those will definitely change, since the center is not going to be at the origin any longer. Now, let's start with our first one. So, we have, no, that's still at the origin. Good one. So we have x minus 4 squared all over 16 plus the quantity of y plus 1 squared all over 25 is equal to 1. So you've been given x minus 4 quantity squared over 16 plus the quantity of y plus 1 squared over 25 equals 1. Well, the bigger number's below your y, so the y-axis is major, x-axis is minor. That means my a squared is actually 25, which means a can just be plus and minus 5, which means my b squared is at 16, so b is plus and minus 4. Now to find my vertex, the center, I set that x minus 4 equal to 0. I get an x coordinate of 4. And then set the y plus 1 equal to 0. You'll get a y coordinate of negative 1. So the center of this ellipse is located at 4, negative 1, which would be right there. There's my center. Now let's go for endpoints. Again, let's deal with the major axis first, being the y-axis. So that means you'll leave your x coordinate of 4 alone temporarily. Now take negative 1 minus 5. You would definitely get negative 6 for a y coordinate. Then take negative 1 plus 5. You would get positive 4. So you got two endpoints of 4, negative 6. 6. So there is 4, negative 6. And then you have 4, positive 4, which would be right there. Now we got to figure out the minor endpoint. So this time you're going to take your x coordinate of 4, add and subtract that 4. Well, 4 minus 4 is 0. You'll leave your y coordinate of negative 1 alone. And then take 4 plus 4, you'll end up getting 8, negative 1. So here's 0, negative 1. Here is 8, negative 1. So we got 0, negative 1. Here is 8, negative 1. Now we can go ahead, let's graph this. Alright, so there's my endpoints, there's my center. Last but not least, let's find the foci. So the center, that's going to then end up being, not the center, the foci. So c squared equals a squared minus b squared. Well, in this case, that's going to be 25 minus 16, which is actually 9. Well, what do you know? This is actually going to work out pretty nicely because the square root of 9, you got plus and minus 3. So the foci, that's based again off of your major axis. In this case, it's the y-axis, so leave the x-coordinate of your center alone. Now take that negative 1 minus 3. You'll end up getting negative 4. Take that negative 1 plus 3, you'll get positive 2. So your foci are going to be at 4, negative 4, and then 4, positive 2. 2, 3, 4. All right, so there is 4, negative 4, my first foci, and then I have 4, positive 2, which is my second foci. So there is everything graphed. Now, let's go on ahead here. Since we've covered both being the major axis, I think we're done graphing for the day. I'm going to throw some equations at you that are not in standard form, and we're still at least going to find the vertex and and all that stuff, and the major axis, but you're going to see what I mean here. In fact, if you'll give me a minute, I want to take these down because it's just going to be too much if I leave them up right now. It'll just be far too much. I need the whole board so I can have good room to show you. It's nice having a magnetic board. I could just stick it on the other side. Alright, let's go ahead and erase all this. So there will be times you're going to be given some equations that are not in standard form. And it's going to be our job to determine what type of conic section it is. In this case, they're all ellipses. So that's the good news. But let's start simple. Let's say you just have x squared plus 9y squared equals 36. So you have x squared plus 9y squared equals 36. Definitely not in standard form. But in order for this to be an ellipse, what is true? The right-hand side has to equal 1. Make your main focus being the right-hand side equal to 1. If you do that, it gets a lot easier. You divide both sides by 36, you now have x squared divided by 36 plus that y squared divided by 4, because 9 goes into 36 4 times. That equals 1. We now have the standard equation of an ellipse where the x-axis is major. So this is the x-axis is major in this case. The center is definitely at 0, 0. Well, a squared equals 36. Or that's a squared, which means that a has to equal both plus and minus 6. B squared equals 4, so that means a has to equal plus and minus 2. Okay, so let's find endpoints. Endpoints, you would end up having, let's see, your major axis is the x-axis, so let's mess with that first. I'll take that x-coordinate of 0 on the center, add and subtract 6 from it, so I'll have endpoints at plus and minus 6, 0. I'm also going to have a couple minor axis endpoints. So this time I'll leave my x-coordinate of 0 alone, but take that y-coordinate of 0 from the center, add and subtract 2, so I'll get 0, plus and minus 2. Those are my 4 endpoints, and then of course I can go ahead and find the foci. C squared equals a squared minus b squared, so that would be 36 minus 4, which would be 32. So c equals plus and minus the square root of 32, which in simpler terms would reduce to plus and minus 4 times the square root of 2. And the foci, once again, are always based off the major axis, so my foci, if the x-axis is major, I'll add and subtract these from the x-coordinate of the center, giving me plus and minus 4 times the square root of 2, then 0. So there are my foci. The biggest thing is getting this into standard form. Okay, that was fairly easy. That one was fairly easy. Now let's do some ones that are a little bit harder. Alright, so let's do a couple of these here. So we have 9x squared plus 4y squared plus 36x plus, actually minus, excuse me, this will be minus 24y plus 36 is equal to 0. Alright, so we definitely got ourselves a quadratic equation here, but it's clearly, and this is going to be an ellipse, that's all we're dealing with today, but we got to get this in standard form. We're nowhere near that, are we? What I'm going to suggest is a couple things. We need to get that constant term out of the left-hand side. Then we need to group our x and y terms together. Let's do both in one step. So this would turn into 9x squared plus 36x plus 4y squared minus 24y is equal to negative 36. Alright, well, in order to have an ellipse equation, for starters, the coefficient on each quadratic variable must be 1. So that means between the x squared and the 36x, we got to factor out a common 9. You would have 9 times the quantity of x squared plus 4x. And then for your y terms, 4y squared minus 24y, we need to factor out a common 4. So that'd be 4 times the quantity of y squared minus 6y. All that equals negative 36. Alright, now, we still have a negative on the right-hand side. This is going to be all sorts of shades of messed up if we try to divide that negative 36 now. What we really need to do is complete the square because we want to have an even square, a binomial square for each of these. So keep that 9 outside of your x parentheses. We'll have x squared plus 4x, okay? Well, half of 4 is 2. Square that, you get 4. Plus, now let's do it with the y. You'll have your 4 outside those parentheses, so y squared minus 6y. Half of negative 6 is negative 3. You square that, you get positive 9. So that's going to equal now your right-hand side of negative 36. Now you got to add what you did with completing the square to your right-hand side. So take 9 times 4, which is 36, add that to your right-hand side. Plus, take your 4 times 9, add that to your right-hand side, you get another 36. So this is going to simplify into 9 times the quantity of x plus 2 squared plus 4 times the quantity of y minus 3 squared is equal to positive 36. We're almost there. All we have to do now is divide both sides by 36 to get the right-hand side to equal 1. What you're left with is x plus 2 squared all over 4 plus that y minus 3 squared all over 9 equals 1. Now you have a format for the parabola that you, not the parabola, the ellipse that you can work with. This is definitely not a parabola, not even close. So now this equation of the ellipse is in standard form. So the bigger numbers below the y, that means y-axis is the major axis, which would leave the x-axis being minor. Alright, so that means my a squared equals 9, which means a equals plus or minus 3. My b squared equals 4, so b equals plus and minus 2. Okay, so let's go ahead and find the center. The center, so x plus 2 equals 0, my x-coordinate would be negative 2. And then y minus 3 equals 0, my y-coordinate would be 3. So the center of this ellipse is going to be at negative 2, 3. Let's find some endpoints. So endpoints are going to be at, let's see, y-axis is major, so let's mess with those first. So we'll leave the x-coordinate alone temporarily. You'll keep the negative 2 on the x. But I'll take that y coordinate of 3, I'll both add and subtract 3. If I subtract 3, I'll get 0. If I add 3, I'll get 6. So my y-axis endpoints are located at -2, 0 and -2, 6. We also got to figure out x-axis, the minor axis. So this time we're going to take that -2, we're going to add and subtract 2. Alright, so if I take -2 minus 2, I'll get -4 for x. If I leave my y coordinate of 3 alone, and then if I take -2 plus 2, I'll end up getting 0, and then leave my y coordinate of 3 alone. So there are my 4 endpoints for this ellipse. And last but not least, let's find the foci. So c squared always equals a squared minus b squared, so that'd be 9 minus 4, which equals 5. So that means c equals plus and minus the square root of 5. Since the y-axis is major, we're going to tack those onto the y-coordinate of the center. So my foci can be found leaving my x-coordinate of -2 alone, but you'll take 3 both plus and minus that square root of 5. And those are the coordinates of your foci. So again, it's all about getting this into standard form. Whether you have to complete the square or divide, well, or complete the square then divide to get the right hand side equal to 1, that's exactly what you got to do. Let's do one more of these, then I'll finish the lesson. Then that'll be it. Let's make it just a tad harder, though. You know I can't let you off easy. Let's do one more here. So what about if... Good one. So we have 36x squared plus 9y squared plus 48x minus 36y plus 43 equals 0. So we're given 36x squared plus 9y squared plus 48x minus 36y plus 43 equals 0. Again, let's kill two birds with one stone. Let's get the constant term out of the left-hand side. Let's group our x and y terms together. So we'll go ahead here, group your x and y terms together. You get 36x squared plus 48x plus 9y squared minus 36y is equal to -43. Looking horrendous already, but again now, we want each quadratic variable to have a coefficient of 1. So for my x's, I need to factor out that 36. So I'll end up getting 36 times, that would end up being x squared plus, what is 48 over 36? That's just simply 4 over 3. That'd be 4 over 3x. Now we're going to have the 9y squared minus 36y. Let's factor out a common 9. That'll end up giving you y squared minus 4y equals -43. Now what we have left is completing the square. This is where it really gets fun. So 36 times the quantity of x squared plus 4/3 x. Alright, so what's half of 4/3? Well, that's only 2/3. If you square 2/3, you get 4/9. So this would be plus 4/9 time, so then you have plus 9 times the quantity of, alright, so y squared minus 4y. Okay, so what's half of -4? That's -2. If you square that, you get +4. So that's going to then equal negative 43. Now we got to add everything from completing the square. So this is going to then turn into, so 36 times 4/9. Well, the 9 goes into 36 4 times, so that becomes 4 times 4, so that's 16. So negative 43 plus 16. And then 9 times 4 is 36, so we actually have plus another 36. So this is going to simplify into 36 times the quantity of x plus 2/3 squared plus 9 times y minus 2 squared. Let's simplify that right-hand side. 16 plus 36 is 52, minus 43 is actually 9. This actually worked out very nicely, because when we go to divide both sides by 9 and make the right-hand side equal to 1, what you'll get is 4 times this x plus 2/3 quantity squared, plus then you'll just have y minus 2 quantity squared equals 1. Okay, well, we still have that extra 4. Here's a little trick with reciprocals. Isn't it true that if we took that x plus 2/3 squared and we divided that by 1/4, that would be the same thing as 4 times the original fraction? So if I divide that by 1/4, think about it. You divide by 1/4, that's the same as multiplying the original by 4, because you want the coefficient outside these parentheses to be 1. Now this y minus 2 squared, you can just put that invisible 1 below it in the denominator. So that'd be y minus 2 squared all over 1 equals 1. Well, interesting, because you have a fraction in the denominator of your x, and you have a whole 1. The fraction's less than 1. You have a whole 1 for your y minus 2. Well, that means your y-axis is the major axis then. Okay, so that means if y-axis is major, a squared equals 1, so a has to equal both plus and minus 1. Now, that means b squared equals 1/4, so b equals both plus and minus 1/2. Okay, we can find the center. Let's go ahead and find the center. That's going to be at, if you set x plus 2/3 equal to 0, you'll get your x coordinate at negative 2/3. And then your y coordinate, so y minus 2 equals 0, your y coordinate would be 2. Okay, now let's go ahead here, let's find some endpoints. We're going to find the endpoints of this. So the major axis first was your y-axis. So we're going to, that means leave your x coordinate for the center alone temporarily. You'll have negative 2/3. I take that y coordinate of 2 and subtract 1, I get 1. I also got to take that y coordinate of 2 and add 1, that would give me 3. And then this is where it really gets fun, when we affect the minor axis of the x-axis. So we're going to first take that negative 2/3 minus 1/2. I'm going to do a little scratch work over here. So negative 2/3 minus 1/2, well, that would end up equaling negative 4 minus 3 over 6, which would give me negative 7 over 6. So I'll end up getting negative 7/6, and then 2, and then one more endpoint for the x-axis. If I take negative 2/3 this time plus 1/2, it gets even more interesting. So negative 2/3 plus 1/2, well, that's going to give me negative 4 plus 3 over 6, therefore giving me negative 1/6. So The other endpoint would be negative 1/6, 2. So we got a hot mess of fractions here for endpoints, but you will have that sometimes. Okay, I'm going to do a little work up here for the foci. So we know the foci is c squared equals a squared minus b squared. In this case, this would be 1 minus 1/4. Well, that equals 3/4. So that means c equals both plus and minus the square root of 3 over 2. Now, the foci, again, are always based on your major axis. That's the y-axis, so take that and add that to your y-coordinate of the center. So that would give you your foci, leaving your x-coordinate alone of negative 2/3. Then you'll take that y-coordinate of 2, and you'll add and subtract that square root of 3 over 2 from that y-coordinate of 2. There's your foci. Got a little bit messy, didn't it? But you will sometimes have that. Okay, so that's it for this lesson. The next lesson we're going to talk about hyperbolas, which are probably the hardest type of conic section. They're not terribly hard, there's just a little bit more going on with them than we have had for the other three. So I hope everybody has a great day. Take care.